Section 3.4 and Section 3.5, Properties and Graphs of Rational Functions. Last time we left off on looking at the behavior of the graph as we approach the vertical asymptote from the left and the right. And if you recall, I mentioned that it is possible that the graph can cross the horizontal asymptote. So how do we do that? Well, we do this by plugging in our horizontal asymptote into our original function. And if we get an x value, then we cross the horizontal asymptote at that x value. For example, let's take a look at x plus 2 over x minus 4. Now, this is the same example I did up here for the vertical asymptote. So this is a good example to do because we will see if maybe my graph is wrong. And in fact, we do have to cross the horizontal asymptote. Well, let's take a look at this. Now recall that, so I'm here right now, right here. Recall that our horizontal asymptote was y equals 1, and we found that out in the previous example, and I'm going to highlight it so you can see what I'm talking about. So I'm right here. Okay, so we found out that the horizontal asymptote was y equals 1 since the degree of the numerator and the denominator are the same. Hence, let's plug in y equals 1 and try to solve for x. So now I'm right here. Okay, so what we're going to do is we're going to multiply both sides by x minus 4 to get rid of the denominator. Okay, that cancels out my x minus 4. And then subtract x to both sides and we get negative 4 equals 2. Can negative 4 equal to 2? No, negative 4 does not equal 2. Therefore, we did not find an x value for where y equals 1. And that means that our graph does not cross the horizontal asymptote. So our graph was correct in the previous example. We're not crossing the horizontal asymptote. Okay, now is the fun part. This is my favorite part of the lecture because we get to put everything together and see how it beautifully comes together like a symphony, and we get to graph. So look at this complicated function that I gave you here. So I'm looking at this one. Did you ever think in a million years you would be able to graph something like this? Okay, so let's take a look. So I just highlighted so you know where I'm at. So first we're going to find the domain, and hopefully by this point you already feel comfortable enough to do that. So we're going to factor, and remember we want to find what x values make the denominator 0 because that is going to be where our domain is undefined. So let's go ahead and look at that. So if you factor, you should get that x cannot equal 3 and x cannot equal negative 2 since those two x values make our denominator 0. And then I just wrote my domain in interval notation and I boxed it there for you. Okay, next we're going to find all the asymptotes. Vertical asymptotes, again, remember that's where our denominator equals 0. Since we already did it we already solved for it in our domain, I can just write that or I guess I did it here for you again. Oh, yes, so one thing I forgot to say, I don't remember if I said this in a different section or not, but one of the things I forgot to tell you is that when you're finding asymptotes, make sure you use the simplified form because notice that x minus 3 cancels, those factors cancel, and therefore I do not have a vertical asymptote at x equals 3. In fact, what do you have at x equals 3? Do you know? Since my factors canceled out, what do we have? If you said a removable discontinuity or a hole, you're correct. That's exactly what we have at x equals 3. So it's not a vertical asymptote, it's a hole. Okay, so we cancel those out and we end up with x plus 4 over 2 times x plus 2. Therefore, our vertical asymptote is x equals negative 2. Now, for the horizontal asymptote, remember we're looking at x approaches infinity and x approaches negative infinity. So if we plug in infinity on top and bottom, what do you get? Do you know? We'll take a look. So I'm going to look back at my original function. Look at the degrees. The degree of the numerator and denominator are exactly the same. So if you remember, if the degrees are exactly the same, then we're going to get the coefficients in front of those variables. So you should get 1/2. Okay, and as x approaches negative infinity, we're going to get the same thing. So our horizontal asymptote is y equals 1/2. What about the slanted asymptote? Remember what we said. If you have a horizontal asymptote, there's no slanted asymptote. And you can also look at the degrees, right? The degree of the numerator has to be exactly one more of that of the denominator. Otherwise, you don't have a slanted asymptote. What about removable discontinuity? We actually just talked about this. We do have a removable discontinuity since the factors x minus 3 cancels out. And our removable discontinuity is at x equals 3. Now, in order to find the y value, I need to plug in f of 3, and we get 7/10, which means that we have a removable discontinuity at 3, 7/10, and this is where we're going to have a hole in our graph. And then intercepts, again, we've done plenty of those x-intercepts. What you want to do is set y equal to 0, okay, and then solve for x. And then y-intercept, set x to 0 and solve for y. Okay, so we get an x-intercept at -4, 0, and we get a y-intercept at 0, 1. Now we're going to determine the behavior of our graph as x approaches the vertical asymptote from the left and the right. Don't forget to pause if I'm going fast. I'm going a little bit fast because 1, we've already gone over all of these individually. And 2, I'm hoping you're pausing and you're doing it on your own before you even hear my answer. And then 3, the YouTube videos have to be a certain amount of time, so I can't spend too much time. Okay, so if we're approaching -2 from the right, remember we're plugging in a number very close to -2 coming from the right. Okay, so I plugged in -1.999. We get 2 over a tiny little positive, and that gives us positive infinity. Coming from the left, we can plug in, coming from the left, we can plug in -2.0001 plus 2. So that means we get a little tiny negative number, and that gives us negative infinity. Okay. Now check if the graph crosses a horizontal asymptote. Recall that our horizontal asymptote was y equals 1/2, so we're going to plug it into our function. Multiply both sides by the denominator so we can get rid of that. Subtract x to both sides, and we get 2 equals 4, which is not equal, 2 does not equal to 4. Therefore, our graph doesn't cross a horizontal asymptote. And now we're ready to graph. This is my favorite part. Now, I highlighted everything in yellow so that you can find your answers easily. I'm zooming out just so you can see. But it's better that if you wrote everything down, you follow along, because now I have to zoom into my graph. So I already drew your vertical asymptotes and your horizontal asymptotes. So we have x equals -2. Okay, that was our vertical asymptote, and then our horizontal asymptote was y equals, what was it, 1/2, I think. Yes, y equals 1/2. Okay. I also drew our intercepts just so you know where our graph crosses. And see, I'm having to go back and look at our intercepts. So we have the y-intercept was 0, 1, and the x-intercept was -4, 0. Okay. The next thing I'm going to do is I'm going to see what happens to our graph as we get closer to -2 from the right. So we're coming this way, -2 from the right, right? Okay. And notice that y is approaching positive infinity. This is what I'm looking at right here. Okay, y is approaching positive infinity. So I know that as I get closer and closer to -2 from the right, my graph is going up. Oops. my graph is going up, okay? Now I'm going to take a look at what's happening to y as I get closer, as x approaches positive infinity. So I'm going to highlight that. Let me use a different color. I'm going to highlight that in green. So now I'm looking at my horizontal asymptote. So notice that as x approaches positive infinity, y approaches a half. Also, as x approaches negative infinity, y approaches a half. So as I get closer and closer to positive infinity, my graph gets closer and closer to y equals a half. And you probably already knew that because graphs tend to want to get real close to their asymptotes. And I also know that we don't cross the horizontal asymptote. Remember that? So we're not crossing it. Now let's take a look at the left side of our graph. So if I want to see what's going on to my graph as I get closer and closer to -2 from the left, okay, I'm going to take a look at that. Sorry about the mess. It's just I can't point. So we're looking at that. So as x approaches -2 from the left, y is getting closer and closer to negative infinity. So our graph is actually going this way, right? We're going down. And then again, we don't cross the horizontal asymptote, so I know that I'm getting closer and closer to my horizontal asymptote. So I'm just going to get rid of some stuff because it is looking very messy here. But I hope that you were able to see all the information that that I put together and used to graph this function. And then lastly, the last thing I wanted to point out is our removable discontinuity. Let's go back over here. Where was it? There it is. Okay, so the last thing I wanted to point out was our removable discontinuity was at 3/7. Okay, and that is right here, if you can see it. Okay, that is 3/7. Let me go ahead and write that down. Not 3/7. What was it? 3/7. 3/7. It's harder to do it on the tablet because on the board you can see all the information together, and here I'm having to go back and forth. But there you have it. So you have your removable discontinuity at 3/7. I have all my intercepts, my asymptotes, and isn't it beautiful how it all comes together? And when we meet each other on Friday, I can do more examples if you like and walk you through them. Okay, so at this point, I would like you to graph on your own f of x equals x squared minus x minus 2 over x minus 3. Now, this would be a good time to pause the video because I'm about to show you the answer. Please do not move forward. Do not look at the answer. Go through the entire steps, find domain, intercepts, vertical asymptotes, horizontal asymptotes, oblique asymptotes. See whether your graph crosses the horizontal asymptote. Check whether you have removable discontinuity. Look at the behavior as x approaches your vertical asymptotes from the left and the right, and then put it all together. If you can do this problem, then you are in good shape. And I'm about to show you the answer now. So please press pause in 3, 2, 1. Where is the answer here? There we go. Okay, so here is our answer. I'm going to remove the lines. It's a little bit easier to see, I think. So we have our domain, our asymptotes, there's no holes, there's no removable discontinuity, our intercepts, the behavior of our graph, okay? So in this case, we do have a slanted asymptote, which means no horizontal asymptote. And then if you put it all together, that is what your graph should look like. You can press pause if you need to check your work. Make sure you have everything. And I'll zoom into the graph. There you have. Thank you, everyone. Have a wonderful day, and I'll see you next time via Zoom.